So yeah, my name is Miguel, and I'm going to be talking to you about modules and dependencies with Require.JS. So it is actually the very first time that I speak in public, so thank you, Brian, though, for the quick intro. So this is a tough topic, right? I mean, there's so much to Require.JS, so I had to come up with a group of functionality that I can actually explain and provide some helpful info for most people in here. So I love the JavaScript community. That's some background about me. Love the JavaScript community. I worked with Brian 10 years ago. It was about creating like a headless browser and stuff. So we've been involved with JavaScript for a long time. But right now I'm actually full-time JavaScript developing cool apps at Symphono. And some of the things that I really like about the actual community is that it's just growing so quickly. It's just huge. And we're very quickly taking over the world. So global, goodbye, sorry. So yeah, I'm a huge fan of open source. I have my little account in GitHub. So we're actually going to be taking a couple of little sample apps for later for the demo. Some of you guys can probably create a couple of modules and help me elaborate on the ease of use of Require.JS. So yeah, I work for Symphono. John just already explained it. So I'm just going to get started on this, right? So if you actually take Require.JS, it's a nice piece of software, but what it actually does, you take all of that functionality that it provides you with. It's nothing more than just a script loader. Its main job is actually to take something and load it up from the internet or locally. I mean, it actually uses script tags. So it's at its bare core, it's actually just a script loader. How many of you guys have actually done anything with Require.JS? Wow, okay. So anybody not familiar at all with it? Okay, cool. So I'm actually going to provide a little bit of a historical context because I think it's kind of important to understand why we even have Require.JS. Maybe we can learn something. So some of the things that actually we had in very early incarnations of web applications were basically primarily just a collection of HTML files. And then in these HTML files, we had inline snippets of JavaScript that provided all this awesome dynamic behavior, right? In this case, we have the date might be wrong, but it was hard to get something representing the 90s. So basically, you had lots of different HTML files, and they had snippets of JavaScript that would basically make direct writes into the DOM, just like that. And that was basically a dynamic website. I'm oversimplifying the crap out of this because I just can't fit a full application, but this basically represents the gist of it. So one of the things that happened in these applications is that we had the same type of code, and actually a lot of copying and pasting, in all of the different HTML files. So one of the problems with that stuff is that you ended up with huge monolithic applications, right? You had an HTML that was so long, and a lot of that stuff was basically copied around, and it was very error prone, right? So we had three primary issues with that type of design. We have monolithic code, we had a ton of code duplication, and then we had just data floating all over the actual global space. What are the problems with monolithic code, right? Monolithic code, it lends itself really well historically to just writing spaghetti code. And if you have actually dealt with spaghetti code at any level, which if you haven't, then you should try it so you know how bad it is. It's basically that you make a change somewhere, and then 5 files later on, you have some other bug that showed up, and you're like, why? I only changed this thing from a -1 to a +1. Why would that break something else? Spaghetti code just has ripple effects on any minor changes that you make, right? So code duplication, I mean, you had stuff just set in the title of your application in one page, then I need to set the title in some other page. Let me copy and paste that. So that's a very overly simplified part of the code duplication, but if you had a chunk of logic that did some arithmetic or something, and you fixed a bug in there, then you had to take that little chunk of code and copy it in a bunch of different HTML files. Super horrible. Developers hated it, and that's one of the reasons why they actually still hate JavaScript, probably. Data in the global namespace, you had a ton of problems with this. You had problems where functions were just overriding each other's data, right? You had a function X that was using a variable A. This variable A was in the global scope, and then some other function was basically changing the value of A underneath the other function X. And it just was really hard to manage then the state of that particular variable. And that happened so much. That's one of the reasons why JavaScript has been historically very bogus. You have a lot of stuff just floating in the namespace that everybody can touch. Horrible, don't do it. So very smart people came together and they're like, yeah, we're going to actually fix some of these problems, right? So they basically extracted out a lot of these inline snippets of JavaScript from all of the different HTML files and they moved them over to standalone JavaScript files. Fantastic. Now, at this point, I think this is probably one of the times that I think that we created some of the first JavaScript modules. I say we, I didn't even know how to code back then. This was, I don't know, so long ago. But so we actually had all this inline scripts moved over to these JavaScript files. And now all of these different files, all of these different HTML files, could actually leverage the code reusability aspect of JavaScript, right? That's fantastic. So now you had to fix a bug only one spot. You didn't have to propagate any changes from one file into a bunch of other HTML files. That was very error prone. So this actually helped quite a bit. So this actually fixed basically the monolithic code aspect of these old applications. Nasty code duplication was also fixed. The data in the global namespace still lingering around. That was actually pretty tough to get over with. It took a little bit of actually ECMA coming together and fixing some of that stuff with the introduction of the closure object. I'll talk about that in a minute. And but another problem cropped up. Horrible problem too. So once you started introducing all of these different JavaScript files, you had to now pay attention to the order in which they were loaded. You had, for example, a file that had some function and it depended on some other file. Some other function had, to be loaded beforehand. So now, if that other function depended on some other function that was in some other file, you had to know exactly the chronological order in which you had to basically load these things. Huge pain because, you couldn't scale this system very well. You had, as the application grew, you would have hundreds of modules. You don't want to really deal with that. You don't want to have 100 different script tags throughout your HTML files and know exactly in the order in which things need to be loaded. So boom, we get Require.JS. Wow, came to the rescue. So at the Require.JS can be very, very overly simplified by saying that Require.JS is an implementation of the AMD spec. What AMD basically stands for is a synchronous module definition. Very simple. Who is a Node.js fan? Where are you? Leave the room, please. No, I'm kidding. Yeah. So this word here is horrible. That word is like just listening to just bad music, right? So the async word is just something that happens so low in the library that that's something that you shouldn't even pay attention when you talk about Require.js. The important bits about Require.js is that it actually provides you with a nice way to define a module, right? A very fantastic way of managing your dependencies. I think that actually dependency management should be like, AMD should be like asynchronous module and dependencies, something like that, because asynchronous module definition doesn't really do justice to what Require.js is. So Require.js provides you with a way to define these modules. And on top of that, it allows you to handle all these dependencies that these modules get. So what is a module? Oversimplification again. Thanks, Jay. Awesome. See these icons? This is made by Jay. So a module at its very, 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 very core is just a self-contained piece of software, right? Reusable. You hope to make that code reusable. That's one of the goals. And that's it. I'm done. See you guys. So a Require.js module, right? So a Require.js module, it looks like that. Require basically has this defined over there. That's a global function that Require.js provides you with. And now what that does is that it provides you, it gives you the ability to feed in a function or an object, but we're going to make it a function. And it basically creates a closure object. And what this actual pattern is modeled after is just the regular good old module design pattern. Who is not familiar with a design pattern? Don't answer, it's embarrassing. No, I'm kidding. So what this is design pattern is actually incredibly powerful because now you have data protection. You see this guy here? You can't see that outside of this module, right? And the way we're exposing this in this module is via a function that basically says greetings. Hey, what do I do with this function? Whatever it does internally doesn't matter. You have no way to override messages. Imagine if this application was loading your social security number and that variable was floating up in space, and then you could have some script injection and then say, hey, get me the social security number. Don't do it. So a way to help you manage that, you create basically a module that creates a closure object. Closure, if you actually read about closure, it's really interesting because Mozilla has really good documentation on it. So I'll provide a link later. So closure, they go back and forth between a function and a special object. Functions are objects, JavaScript. So one of the things is that when this variable is created, and an inner function, you say this function is actually what's creating the outer encapsulation. When there is an internal function and a function inside that is using a variable outside of it, in this case, it creates a closure object. A closure object is a very special type of object that keeps track of all the functions and what variable that function is actually accessing that are basically designed, they're actually defined in the context they're running in. Well, not the context that's in JavaScript context, but in the place that we're defined in. So I'm probably not even explaining it very well, so I'll just give you a link a little later and you can read up on it. Important, very important. So one of the things about Require.js is that modules are tied to an ID. And the ID is basically, that's why I left the file here. The ID is basically generally extracted out of the name of the file. So when you say require, you say something. That require is basically crafted from the name of the file. So the module definition is tied to the file name, and yeah, whatever that says. So what we're going to see is that whenever I need to use this particular module, I'm just going to say require greetings. Now, rough transition here, but Require.js has a very fantastic dependency system. So the module we defined previously, we're going to be able to use it later by simply saying, hey, load that module as a dependency. So what this dependency system is basically doing for you is that it's loading all these dependencies that your modules have. They're loading them transparently. What that actually means, in my head, hopefully you understand, is that all the inner dependencies that a dependency has, 5, 20 levels deep, it doesn't matter. The dependency tree is irrelevant to the actual module consuming it. They're actually all loaded, and whenever the module is ready as a whole, regardless of the stuff that is being downloaded in the background, whenever the whole thing is done, you get a handle of it, and then you can use the module. You don't have to worry about sequence. You don't have to worry about whether that file it doesn't exist anymore. I mean, if the file exists, then it's just going to get loaded. If you have 20 copies of that same file, it's just going to load the right one that you told it to load. So this is actually now basically making use of the greetings module that we created before. You see the greetings there? This greeting is basically referring to the name of the file. So that's very important. That's how Require.js does its work. It basically defines a module, it ties that module to the name of the file, and then later on you can actually say, hey, I want to define another module. Define, pay attention to that. And then here's the tricky part about this. This is the tricky part about Require.js. The parameter that defines all the dependencies is actually an array. So the good thing about it is that you can actually define 100 of these dependencies. It doesn't matter. And then what will happen is that underneath, Require.js is going to go through and then resolve all the dependencies that you have there. And it's going to go through the dependency tree of each one of those modules, and it's basically going to load them. And when all of these dependencies are ready, you're going to get this function callback, and they're going to be basically in the arguments here in the same order in which you defined them. So it works pretty clean. It cleans up a lot of code. So I get greetings, and you can call it as a function. And oh, greetings. I just noticed that. So in this case, you have greetings. I'm exposing the, oh no, cursor, horrible. So I return a function there called greetings, and good, proper spelling. And I call it, and I call greetings. Oh, this is one of my favorite parts, right? So this is your spaghetti code. You've taken it, and you've put some Require.js aspect of Require.js in it. And that's just generally what applications look like, right? I mean, you have one ginormous set of code, and Require.js allows you to just put little labels on your pieces of code. And the labels can have dependencies on other labels and stuff. But then when you actually say, hey, out of this rat's nest, I want to get A, it goes through and it figures out and you just get A, right? And at this point, A might depend on other stuff, and other stuff might depend on other stuff, and it's irrelevant, right? By the time you actually get this callback, this A is going to get exactly what you're expecting out of that rat's nest. So, more modern approach. I'm trying to close the loop. I don't know if I lost you guys, but the more modern approach. Now, we had the initial stuff where you had HTML, actually a bunch of HTML files, and some of them had a lot of copy and pasted code. Just imagine that. And then, you know, in this case, we're actually going back to just the same HTML, but now we're just loading up your dependency manager. And you're saying, you know what, when dependency manager loaded, I want you to load main. Now, if we go back to what I was trying to explain earlier on about module IDs, so this guy is asking for main. So at some level, I'm going to be expecting that there is a file called main.js. One of the things that Require.JS does is that when you're actually getting a dependency, it drops the JS. It's assuming that it's a JS JavaScript file. That's what it's supposed to do, right? There are some plugins that allow you to load up different types of files, and I'll talk to that about that a little later. So, oh man. So we have our main.js. Our main.js is this guy here. It has all of those script files. You have app, you have common, utils, context, hiring. You can have whatever. And then in it, you're defining basically a function. That will automatically create, or at least give you the ability to create a closure object so that you can keep your stuff nicely tucked away, not exposed to the world. And you can use all of those dependencies once they're all resolved. So that's basically translating all of the stuff that we had done earlier on into a more modern approach to Require.js. Yeah, sorry, what's up?
Does the order have to match between the string array and the arguments?
Let me just check. Yeah. So I just want to know if I mistyped something. Yes, they match.
I'd say, do they have to match?
Well, I mean, it doesn't matter, because that's actually one of the things about Require.js is that you can put this one out here, shuffle them. Actually, you should create a little random number generator, swap them out in order. The only important thing about this is that the order in which you specify them here is the order in which they're going to show up in your arguments list. So they don't matter as far as loading in order, but they're all going to be loaded up simultaneously or whatever, and they'll come back in that order.
So if we just renaming the arguments,
I could have called this guy instead of context. I could have called it just called it, I don't know, Schwarzenegger, something. Yeah, it doesn't matter. Yeah, what's up?
What is the best practice if your JavaScript file is actually in a folder instead of like all in the same reduction?
It's tricky question. So what you end up doing with that, the question was, what do you do when your modules are actually in a folder hierarchy? The part about that is that this is just a file they're expecting to be in the same directory as wherever the module is. The module calling it is. Actually, I'll talk to that a little bit later. It's all based on the relative path of the base URL. But if you have that inside of a directory, you just put the directory name /hiring. So if you have 20 layers deep, you go in 20 layers deep. I'll give a couple of tips on basically how to clean all of the pathing up in a little bit in the demo app. But yeah, so you can have those modules be in whatever directories that you want. So we're gonna see here. Oh, okay, good. Problem solved. Did we solve all the problems? So far we have, right? So we've basically did the monolithic code that was solved a long time ago. We did the code duplication. Hopefully you're not copying and pasting. I mean, that's the reason for modules, guys. Come on, don't copy and paste. It's horrible. It's not healthy. So data this is fixed. Closure object. Remember, closure object fix this. You basically encapsulate that data in your module, and that's no longer exposed to the outside world. So we're good on that one. The order of the scripts don't matter. I mean, you can to your point, right? You can load them up in whatever you want, and the dependency manager is going to basically go through the dependency tree of each one of those modules, and then it's just going to figure it all out. And by the time you get your callback, you're going to have all the stuff there. It's beautiful. So Oh man, it's demo time. Awesome. So now we get to see some code. That's me when I was like 8 years younger. And so one of the things that I'm going to be concentrating on, specific to Require.js, is going to be base URLs. I'll talk to it because I'm not going to be doing much with it, but it's really important to understand paths, shims, and packages. So base URL is basically where you tell Require.js where your actual application is. You basically use base URL to tell Require.js everything is relative to this path. If you don't provide that, then Require.js is basically going to go through and say everything is relative to where the main file is. I'll show you what the main file means. Path, sure, I'll go through this. So path is basically a way to map a name, a module ID, to a file in whatever directory structure that you may have, right? So this is a good way to do things like you want to load up jQuery. And every time you load a jQuery, you don't want to put a 20 levels deep path before you get to jQuery in each one of your module definitions. So you just basically map jQuery, and then you provide the path. Shims basically is a good way to allow you to load things that are not modules. One of the problems with Require.js that is fixed by shims is that it's expecting things to be modules. It's good. Good practice. Create modules, guys. When you go home, you should create your first module if you can. Shims. Packages is a good way to basically map groups of files, similar to how Node.js does it. So Node.js has this node modules thing, and it has a file inside of it. So packages allow you to basically give a name to that package, and it will automatically call that main.js or index.js or whatever main file that you have in it. It will automatically load that. So that way you don't have to call your module name and then the file name. We'll go through how that works actually, because it's a little complicated to explain in words. So let me see here. Code. Good. Ha. Everybody see that okay? That okay? Thank you. So index.html, guys. This is very fundamental. This is back to the 1990s example. You still have your index.html. You have to basically load up your Require.js. I'm doing something a little different here. There are a couple of issues with Require.js plugins that require you to load some things before others and stuff. You'd think that they would have it figured out since they're using Require.js. But things like the CSS plugin, it needs to be loaded before some things are loaded. I don't even remember. So I resolved the problem a few years ago, and I don't look back. So how you resolve that is that you basically load Require.js, you load up your require config, which is where we're going to see all the path, base URL, packages, and all that junk that basically makes your Require.js understand your application. This is basically the first step into your application. That goes back to my inclusion of data main pointing to main. That's equivalent to that. I broke it out because I basically have to load this guy first, then I have to load the Require.js config, and then I'm loading the main. So the first thing that we gotta see, right? We're gonna see how this Require.js is basically configured. Ha, nice. So paths. So the gentleman over here was asking, how do you basically do files that are in different directories? So in this case, I have my directories being libs, backbone, libs __, whatever. That's just how Bower is managing that stuff. I'm using Bower to get all the dependencies I have. So I used a couple that are not managed by Bower. I just dropped them in some JS directory just to kind of illustrate the point that you can use Bower or whatever script, it doesn't matter. So in this case, I'm basically giving a very nice name to a nasty directory structure. So anytime I require backbone, Require.js is going to go through and say, hey, that's inside of libs backbone. So that's our path, important. Our shim. Our shim has a couple of different purposes, right? It can allow you to, it will allow you to take something like jQuery. jQuery is not a module. Now it's going to that conversion. But jQuery has it's still a globally exposed library. It does have internally, it will expose itself as a module when it's loaded, if it detects that it's running on, if AMD is running. So that's not a good example, but a good example is actually Backbone. Backbone does not know how to expose itself as a module. So you basically have to define it in the shims, and then whenever you have exports, what that means is that Require.js is going to take whatever output it is from loading this thing, and it's going to then put it in its internal cache as a Backbone object or function or whatever that was returned. And one of the things that is important about the shims is that this is how you actually define dependencies for things that are not modules, right? So why is that important? Backbone doesn't know how to load jQuery or underscore. Generally, with a traditional approach, you put them directly in the HTML as regular script files. You put in your entire path for the script file for jQuery and underscore. And Backbone, then you define it right after that. And that goes back to the whole thing of knowing the order in which things need to be loaded. Backbone needs to be loaded after jQuery and underscore. But in this case, you don't need to do that. In this case, you're telling Require.js that, hey, whenever you actually load Backbone, make sure that you first load these two guys. And then if you look a little lower, yeah, I'm actually also specifying the same thing for underscore. I'm saying that whenever underscore is required, export it as a underscore, as a low dash. So here's basically how you define your packages. Very simple. You have an array of strings. So what this allows you to do is that you can then do something like require app. And when Require.js goes through the process of resolving your dependencies, it's going to see, hey, app is a package. I'm going to go into that directory because it's assuming it's a directory, and it's going to load your main.js file. By default, it will load main.js. There are ways for you to basically map app to some hash object, to some JSON, and you can specify the actual file name that you want to load by default whenever app is invoked. But the concept is that when you actually say require app, you actually go through the Require.js goes through the process of saying, hey, I'm requesting app, I'm going to load main.js. And we'll see that in a second. So we've gone through the require config. We are going to now see what is inside of main. Now, one of the things that you're going to see here is that main is in the same directory as the where everything else is. I didn't specify a main. Okay, yeah, that's why. I didn't specify a base URL, but if I were to specify a base URL, you can make it whatever you want. What this will do is that it's basically going to tell Require.js to load things relative to base URL. So at this point, when I do load main, Require.js is going to look for main, not in SEM require, it's going to look for it in the .. So, but when you don't define it, it basically will load based on where index HTML is. So what's inside of main? That goes back to the definition of app. So you see in there, I'm actually saying just define app. Get me whenever you define this module, make a dependency against app. So get me that. And that will basically go through the process of going into app and then getting your main. So that was a very nice, clean way to basically get this automatically loaded. If you actually didn't use, packages, then you basically have to call it this way. And it becomes a little more verbose, and I like it. I'll tie that back to a concept on how to use routing, in this case, to leverage packages. I'll go through that in a second. But when you actually use routes with clean names like that, it becomes very easy for you to automatically load modules based on a route change. So in this case, I'm actually loading up the module app. And one of the things that I was trying to talk about was that this main.js has a bunch of dependencies. And these dependencies are going to be automatically loaded. They're going to be loaded at runtime, so it's not like all the stuff is loaded up front, which is one of the problems with script tags. I know minification will fix everything, but we'll talk about that in a minute. So when you load main, it will basically load up all of these things, And by the time this main file, your main app file, it gets its callback here, that's exactly when app it has already resolved all of the dependencies, all of the nested dependencies and whatever it is, and then you're ready to use that module. So all I'm doing in this module, this is basically a very simple bootstrap to say whenever the actual document is ready, I'm going to instantiate app, and I'm going to pass into it, this is more backbone stuff than anything else. I'm going to pass the body, but that's not relevant. I'll talk about backbone at another point. Mark is not here. So I was mentioning that Require.js has plugins. Require.js actually expects by default that everything is going to be a script, which is good, right? But James Burke, guy that wrote this awesome software, he basically realized that not everything is a JavaScript file. You got other assets. You have assets like main HTML. It's just a text file. So there were some people, I don't know if it was him actually, may have been him, that created the text plugin. So what that will do is that it's going to resolve that as a dependency. Obviously, it's a text file, so it's not going to have more dependencies. It would be weird to have dependencies in an HTML file. But that's going to load that as a dependency for this module. And you see that CSS below is also going to be loading that up as a dependency for this module. So something that happens with Require.js is that once it resolves a module, it will cache that result. And that's important because you can then require this module multiple times, and you're always going to get the same thing. And it will only get loaded once into. It will only get downloaded once from the internet or local, whatever. So we have templates, transition, countdown. That touches nested dependencies. That touches shims, and that actually shims. Yeah, I didn't even do that. So, okay. So I'm actually going to go through how I leverage packages with routing. This is actually very interesting. I like using it. And so one of the things that the app uses is a routing system that basically takes the hash, and then it will go behind the scenes and say, hey, I want to require whatever package matches that hash. So if you change the URL from app to dashboard, Require.js, that URL is the URL change is basically going to go through the routing resolution, and it's going to say, hey, require this package, require dashboard, require tests, require your module. So what that will do is that it's going to tell Require.js, load that up. Require.js is going to load up all of the dependencies for that module, and the transition component basically goes through and swaps views in and out. That's more of a backbone thing. But at this point, I'm going to take a breather and see if you guys have any questions.
We're using jQuery on the app. I'm guessing that one of the other dependencies has jQuery in it.
Mm-hmm.
And you follow that path.
Right, so you got me. So one of the things that I do in here is that I have an opinion on how to use some of these things, as you probably do too. I consider jQuery in my application to be a global dependency, much like what the string class is in many other languages, right? I don't like to have to explicitly request jQuery in every one of the modules that I have, because one of the problems that Require.js has is that it's very ceremonial. I mean, it likes you to write all kinds of dependencies that are always going to be loaded anyways, and you should just assume that they're there. And I don't like to treat those as dependencies. They're more like bootstrapped around the application because it's part of the application's ecosystem, and it's not part of like a requirement type of thing. So that's why it's not in there anywhere. But there is the cache buster. Anybody here has anybody here had problems with caching in IE or Firefox or Chrome, whatever? Oh man, this is a pain, right? So it's a pain because you have to come up with a way to change your URLs, and AJAX requests are very, very bad with this. And you have then Require.js that also has the same problem. It's making requests out to the network, and when you don't put the little cache buster in it, you run into problems with caching. So one of the things that I added in here as a bonus was basically a system where I created this little cache buster, and it's really simple, right? The cache buster is loaded as a dependency. So whenever main is requested, main is always going to be requested. That is the main file that is actually in the index.html. So whenever main is loaded, it's going to go through and it's going to say, hey, cache buster, load itself, load yourself. And then this cache buster has further dependencies. The dependencies are basically Backbone, MD5, some crazy library, and this large, awesome fonts. They're done in this sequence because when main.js is loaded, this guy here is going to load the caching system, the buster, but I don't want these files to be cached. That's why I put them as dependencies, so they're loaded before the actual cache buster is loaded. And the reason for that is that these files don't normally change. And right now I have a very bad example. I mean, generally you would put those files in with like version like -1.2, -1.5, and so forth. That way, when you put in the new version, this is going to change over there. Backbone, you have Backbone -1.5, and when that version changes because you put in a new version of Backbone, that's automatically going to bust the cache anyways because the file name is different. Yeah?
Can Require.JS handle semantic versioning?
Help me understand that.
1.3 or above?
No. That's an unfortunate truth. Yeah?
Did you say that it loads all your scripts asynchronously?
Yes.
So what if you want to execute some code like when you normally would do DOM content ready or something the page is ready?
Okay, that's actually pretty important, right? I'll show you here. So when this guy is loading, this main HTML loads, first thing that it's going to require is going to be your main. This main is going to be loaded. It's going to require app, but app is not doing anything because you haven't instantiated it yet. You're just loading it, but you haven't used that module. But all of that is contingent upon its use is contingent upon basically the loading of the DOM. So that $sign function ready is basically at that point you execute your function of your app constructor, and at that point you're assuming that the DOM is ready. That's a very important step actually, because a lot of times if you load things up before the DOM is ready, you start interacting with it, and then you start losing parts of your work going into the DOM before it's fully loaded. But this is one of the reasons I bootstrapped this into a very simple main. Basically, this is what all the mains look like whenever I write them. I say load up main, and the main is going to load up whatever simple app constructor it needs to, and then it's only going to instantiate that app function whenever the DOM is ready. That's what the $sign.
So you can always assume the DOM is ready.
That's exactly what that. Yeah. So this chunk of code is actually jQuery. And whenever that is actually executed, whenever that function is executed, that is, you can assume, I guarantee it, or Jan Bresig will guarantee that the DOM is ready to be, that is ready for game.
I guess my question is, if you remove the DOM ready jQuery.
Oh yeah, this thing will bust wide open in many places. The modules are not,
Right.
but the execution of the content of the modules, yes, because I only require the modules, right? When I do whatever I need to with the modules whenever I want. So if your module is actually loaded and the module upon loading is doing something with the DOM, then yes, this whole thing would break. So yeah, very good question. That's actually a sneaky one, because a lot of people are like, well, when do I start loading my stuff? When do I actually instantiate my app? Why do I want to wait until the DOM is ready? It's because if you start manipulating the DOM, you're going to start breaking stuff. And probably just your application won't display correctly. I lost my train of thought. Okay, so I'll show something kind of interesting. This thing is actually scares me a little bit. Sorry.
Question.
Yeah.
For the cache buster, why do you need fonts and CSS?
Yes, because this is very good. This is the version right here. So if I were to get a new version of fonts, this number would change. And then the cache buster is just not going to even.
I thought cache buster just had some implicit hash on your URL.
I'm actually going to, I'm going to open up cache buster right now, and I'll show you what it does. So common cache buster. So the cache buster here, what it's doing is that when it loads itself up, it's basically telling Require.js to put this URL args. This URL args is basically something that is going to be appended to every one of the URLs that is going to be requested via Require.js. So one of the things that I do with this one is that I like to do this. I put a version file somewhere. And this version file will basically get updated whenever your build system says, hey, you're ready, you got a new version of your application, right? So what this gives me is that the version is always going to be the same until you actually publish to the public a new version. So Facebook, for example, or Google. They don't want to have all these files downloaded every single time that you go to the website. So that's why they have some sort of version control. Or actually, one of the things a lot of people do is that they have an expiration tag in the HTTP. And the HTTP basically, with the expiration tag, tells the browser, hey, after so much time, just kill that file and reload it. With this approach, you basically get a version, and you control whatever version that goes into that file. So if you, for example, change this file, this version 1.00. So if you actually wanted to publish a new version of your app, you change that because that's just what the build is. And all of the files in your app that had 1.00 are going to be invalidated, and all of the ones that are Require.js is basically going to download all brand new ones that are 1.01. That's what the cache buster is doing. I'll show basically what the traffic looks like in a second. So you can see the actual, how the whole thing works.
But why do you need CSS? I don't know.
Oh, CSS. Okay. The CSS is an external library. Sorry. So here's generally what I like to do. External libraries, I don't version control them as much as I would probably like to. So if I get awesome fonts, that's some external library I have, and if I put a new version of it in my system, I want that version that I got from that system to basically trigger the refresh in the client side. I want to treat that as an external dependency. I don't want to treat it as part of my code. I only want to control the caching of my code, right? Because one of the things that happens is that if you didn't do this caching step, I'll actually illustrate it so you can see a little better. If I didn't make that the CSS file in Backbone and jQuery or MD5 a dependency of the cache buster, these three files are always going to get downloaded, always, whenever that version changes. So if you, for example, deploy version 1.0.1 of your application, these dependencies, external dependencies, are going to get reloaded, and they haven't changed. So that's a way for me to break out what's external and what's part of my app that I want to refresh. And I'll show in a second how it actually translates to in a real app or in a demo app. So, so at this point, I've covered. At this point, I've covered a lot of stuff in Require.js, and I don't know if anybody has specific questions about Require.js before I dive into the little demo here, the little demo app. Some people asked about RJS, some people asked about Ember, some people asked about Angular, so I know somebody has questions. Yeah, what's up?
Is there a server-side component to it? Can it do concatenation, or is it always?
Yeah, that's RJS. I will. So what I'll do is that I left that as a kind of like open mic. It's not open mic. I have the mic. I own it. So I'll actually open it up for questions about that later. So I have on that list, I have RJS, I have Ember, I don't know if I have Angular. I have a couple of other ones in there that are just topics that came up, and I'll just talk about them. What's up, Jay?
With back towards the beginning, when you were specifying the string array of modules,
Yeah.
and then pass the variables into the function.
Yeah.
So with Angular, you don't need to specify the string version ahead of time. Is there a way to do that same thing in Require.js, that by convention it will just go look for the module based on the variable?
Right. So not really. If you do, then I'd love to hear it. But one of the things about Require.js that is different from Angular is that Angular knows its ecosystem. It knows where things are. It has just knows, right? Require.js is a little more multi-purpose thing, general purpose. So you kind of have to tell it where things are. And that's actually one of the reasons why I don't encourage mixing Angular and Require.js. I don't know much about this topic. Brian Ganicio might be able to help with that. You know, when it's like having multiple libraries that do string concatenation. You know, you're overlapping a lot. So I don't know exactly why you would need Require.js and Angular, but what Angular is doing behind the scenes is one of the reasons why you don't need Require.js in it. It's loading those things automatically. Yeah.
Other common AMD modules that Require.js?
Other, I don't know off the top of my head. James has written a couple of them. There are a few out there. I haven't used them personally, but I don't remember off the top of my head names. I know there are a few that are a lot smaller than Require.js. Require.js, one of the problems with it is that it's really large because it addresses so many corner cases, and that's all I use. But other ones, I don't know. I can Google them with you after this, and I'm sure we'll get good matches. Anything else? Ember? Anybody Ember? Oh, I don't know Ember.
That was another question. You're talking about loading things as you need it, but at some point, especially with single-page type apps, you want to have all your scripts, you know, in one file that gets there fast. And you have everything in memory, so I don't know how would you need Require.js at that point.
It's like saying that you're not going to write C++ because you were executing at the end some executable. I mean, you want to develop against something like this. You want to be able to debug into it. You want to have something that you can say, hey, I loaded this module. I know exactly where it is. Let me put a breakpoint in there. Let me fix it in there, and let me check it in. And then generally you have a like a build process, basically, that puts all of that junk together, and then it puts it out in the server as a single file if you want. I have not found a case where minification has that great. Sorry, don't start throwing things at me. Where minification it has some better benefits. It has some benefits over just having all the little modules that are loaded at runtime, because it loads everything up front. But in general, you are loading so little up front, and as you progress through an application and things are cached so effectively, that you know, I've never really bothered to pay too much attention to concatenation. But that's one of the things that is very important with our JS, right? There are some things that you really want to do it for. Like there are some things, for example, with IE7. IE7 is only is bottlenecked at 2 threads, right, Jay? It only can handle 2 threads for downloading things at a time. So when you have an application that needs to download 5 or 8 different modules before it actually, before you get an application fully loaded, then you start running into some thrashing in there. So yeah, there are some reasons why you need it. But yes, generally that's what you do in a real application.
So, clarification, I kind of got the impression earlier that all that dependency stuff that happened was making sure that everything was loaded before you ran the code.
Not.
Or does it load it when it's needed?
When it's needed.
Okay.
Yeah, so it's a runtime. You don't load everything up front and then, you know, only use a fraction of it. Yeah, what's up?
So when you say it's only run at runtime, does it actually go through the whole dependency and load each one of the dependencies so that it can call those? For
the modules that you're loading, right? But in applications, it's generally.
You call it programmatically. If in your config you define that, you call it later programmatically, then it would do it after runtime, right?
Right. At runtime, it will resolve the dependency tree, and it will basically load all of those things for it. However, if that's the only module that you are requiring in your app, and your app has hundreds of different parts of your page that are not loaded, they're not displayed, then those modules are not going to get loaded. I mean, that's up to you. You can load them all up front if you want, just kind of defeating the purpose of having a modular system to a degree.
So you just call require in your executing code to load it as needed?
Right. Well, you don't necessarily do it. This is actually an interesting thing. It's one of the confusing things about Require.js. You don't do a require on it. Generally, your module that you put in, you created as a define, you define the array with dependencies in it. So whenever that module is loaded, it's going to basically tell Require.js, hey, go and figure out these dependencies. So when you don't tell Require.js load these things with a require call, you can just put it in the array, and Require.js is going to implicitly go behind the scenes and treat those as dependencies. You can do more of the common JS approach if you wanted to, where you have explicit calls to say require X, and that's going to download it also. But it's
I guess you get a single entry point in your app.
That's your require main.
Requires everything he needs, and that guy requires everything he needs.
Yeah.
And that all is getting resolved before you actually run the code. Then you are essentially loading everything beforehand. Or am I completely misunderstanding?
Yeah. There's a part missing. So here. So let me show the traffic here. So when I load this up, I have I have a handful of things that my application is currently loading based on what dashboard is. And when that thing finishes loading, there's a bunch of stuff that is also being now downloaded at that point whenever it's needed by Require.js. See, when my application, the new app thing that got instantiated, needed a bunch of other stuff, and that's when all its dependencies were loaded. So it does it at runtime whenever you require a module. And if the module needs other stuff, that's exactly when they're downloaded. So that's one of the things about the routing system here. It shows basically how I'm going to download another set of dependencies. I'll show you that in a second. So in the transition, so no. So basically, whenever the actual URL changes, I'm basically registering some listener on the route. Whenever it changes, I'm actually going to get the name of the URL. So when you see in the browser hashtag something and that changes, I'm going to get a callback in here, and this is going to be the value for it. This is how you require a new module. And you can provide all of your dependencies here. You can provide an array similar to how define provides it. Define is when you're defining a module, and then you can explicitly basically establish dependencies for that module by passing in the array of items. But if you actually want to be in the middle of your code and you say, hey, I feel like loading something else now, because you clicked on an event, and in that click event you load up a couple of other icons that you want to display at runtime, then you can just do require, and then you pass in an array of the different things that you want to require, and you get exactly the same type of callback and the same matching parameter thing that a define has.
That's how you load it after the fact.
Exactly. So, yeah, exactly. So we'll debug it. So what will happen is that I'm going to change that up. Timer. Sorry, guys. That was actually going to be a nice little intro, but we'll just skip the intro. Screw it. So there is my my require. My module name is actually the module was already resolved. It was supposed to be a dashboard, but at this point I got my view. That's a constructor. I'm going to let it execute. It executes. So if I were to pass in tests, for example, I'm actually going to get that. Going to call in Require.js. Nasty. I'm going to call in Require.js. It's going to load up. Man, the font sucks here. So at this point, the require is going to load up these dependencies, and whenever the dependency is loaded, then it's just going to go in and get you your callback whenever the module is loaded. So you do have that stuff around, and it makes sense for some instances, but the more common approach is just to have your module know about all its dependencies. In this case, this is a special case. You don't have routes just lingering everywhere trying to load things dynamically. In this case, that goes back to packages. It matches tests. For example, test is a package, and when you have tests coming in through this route, it will automatically tell Require.js, get me tests. And what that tells Require.js is basically, hey, I have a package called test. It will automatically load main.js. So it cleans out that part of the URL. It helps you match it really nicely to a route, and that package is going to be beautifully handled by Require.js. So that's, oh yeah, that's right. So I'm going to get rid of the... Does that answer the question? Okay,
Yes.
cool. Yeah.
What's the difference between using define and require, for examples?
Define what's that?
Define and require.
The functions.
Yeah, you want to see how I was using it in the code you said?
Well, I saw that you're using require like here in the middle, but in the beginning of the files you're using define. So are there any difference?
Yes, yes. I'll show back in the code. Scroll up. So define is what defines the module. So this is the part where you say, I want to require a module. And that's where you actually are asking for a file that is basically attached to the module ID. So your file being the module ID will translate to this file getting loaded. And then Require.js is going to go through this define process. Define is just a call that it exists instead of Require.js. So when Require.js, when you call define, Require.js is going to say, oh, okay, you're passing me an array with all these dependencies, and you're passing me a callback. So what it does is that whenever Require.js gets a call to load this module up, it's going to resolve those things, and then it's going to get you your callback. Now, in here, your module has already been loaded. And at a later point, you want to basically have this module load up other dependencies, other modules. And that's how you do it. You basically are explicitly calling Require.js to get you something. Does that answer the difference? The difference is that that one defines the module, and this one allows you to explicitly call something after the module has been defined. Well, are you going to the bar? Beer? We'll chat about this. It's actually, this is a bit of a pain in the neck to actually get your head around. So
I can assume the root is the hash like on line 4.
yeah, this root is the hash. So what happens is that this is your hash handler, right? So the routing system has to be loaded before it can become responsive to hash changes. So what happens is that the application, I'm going to go back in here. Where do I load that thing? So my main.js basically, okay. So what I'll do is that I'm going to walk through the flow that Require.js does. It's a small application, so it's no problem. So you have your index. Index basically is going to require main. You see now, this is exactly how the whole thing is triggered. You have your require. That's basically making your initial call into the system. Everything is initiated by a require call. Now, this require call is going to go out and request something called main. Main in this case maps back to the file main.js. So when you have your file main.js being loaded, what Require.js does is that when it downloads this file, it's going to execute that. This is a script, so it executes the script. And as the script is executing, it's calling define, and that's a Require.js function internally. And it's used basically by Require.js to say, hey, you're defining a function, you're defining a module, and this module has these dependencies. The dependency that it has is app. So then it resolves whatever app is. It goes through and it trickles down into the other dependencies. It gets those two. And then eventually it returns app. But that is the aspect of resolution of a module when you're defining it. Right? When you go back into main, oh, embarrassing. So when you call main here, that is basically initiating the request. You're initiating the request to get a module. You're saying, you know what, load me this module. And that's exactly what the hash is doing. The transition module is actually doing the same thing. It's defining a module. Sure, cool, because somebody requested it, so it needs to basically get these two dependencies. And whenever it's activated basically by Require.js, then you have the ability to, at a later point, call other modules. And that's how you basically say, hey, I already loaded myself, just require that module whenever I need to. And you get your callback. That's how you know that your stuff is done. To some people's point, there are other module systems, and I love promises. I love promises. I mean, my wife is jealous. There are some tools out there that basically will do require, and instead of doing a callback, they just return a promise. I wrote a module system that returns promises because I love promises. They're good for you. So that's that. Let me see.
Because
I'm sorry, what was that?
Yeah, talk about you're returning registered route, but you have all the functionality to handle empty route, which is not returned when you return.
So you want to know what the difference is between register route and then the other stuff that gets executed?
Yes. For example, when you go into this module, you're handling empty route. So if I don't have anything to do at all, it goes into the dashboard. But then you're returning register route as this module is returning, right? I'm guessing that's returning to those who made the penalties module.
Yeah, you know what? I made a boo-boo. I could have just not returned anything. I mean, what this implies is that whenever you require this route, this route handler, whenever you require it, you are basically actually no, it's not a boo-boo. It's working well. You are basically implying that you have code that can be executed, and this goes back into. Let me show you where that's used in main. So in main, whenever is it main? So transition. Where's my transition? Give me my transition. There. So whenever the app is initialized, I'm passing something into it. This is requiring the module. We're just talking about the route handler for transition. This is returning a function, and I'm calling that function at a later point to say just do something with it. Just I got a function. That's my module. Call it. Do something.
But you're not required to return something.
You're not required. No. No, you're not. So I mean, we're getting lost in some intricate details about the implementations of Backbone, but this is good though, because it's basically showing some somewhat real uses of it. It gets a little complicated sometimes, but okay. So I don't know what I was going to talk about. Yes, okay. The app. I'll show the versioning thing of it. It's pretty interesting. So here's basically the aspect of the versioning. Require.js doesn't need to change version, config, or these two dummifying detector are basically things that are Chrome. But MD5 requires CSS and fonts, awesome fonts. They're external things. I don't want to manage when they get cleared from the cache. I don't want to do any of that. The mistake I made in this case is that this guy should have had a version attached to them, so that if I were to update those libraries, that version change is going to be just a different file name as far as the browser knows. And when there is a difference in the file name, then the browser basically is just going to get a fresh copy. It's just going to say, get me that one. Now, for jQuery, the same. I don't want to be loading that up every time I have a new version of my application being loaded. But after that, my version gets cached. And the reason why that needs to get my version doesn't get cached, the reason why that has to be busted every time is because if the version changes, I basically need to reload that every time. I basically have to tell the browser, make sure that you get always the version file. That's why this thing is a timestamp. Looks weird. But this little thing makes the browser think that it's a different file. That's the caching that gets busted. And then the other files that are basically pertinent to my application, if I were to disable my caching system in my browser, these files would only get loaded once. And if I come back to this application, I'm going to always use the cached version until the version.json changes and it has a different number in it, which will basically propagate into this being a different thing. And then it will basically tell the browser to load up a different version. I don't know if that helped. Did you guys kind of follow that? The cache buster is actually a pretty good thing to do. What's up? Good, awesome. Oh, I thought you were going to hit me behind the head. Cool, so, well, is it, wow, 7:30. You guys want to continue for another minute and I can show the little app and you guys can download the chat and write a little module and do something?
Sure.
Cool. Awesome. I know we're all thirsty for beer. I'm dying here. So I created a few little demo apps. It's in the GitHub. So if you guys got your laptops out, download it from there. And what I have done is that I've basically tied the little dashboard app that I was just showing. I've tied it up to a server that is running in Heroku. And there is an actual module in that little sample app that is there's a module for chat. It's called chat, simple chat. So you're going to be basically creating a little define in your main.js and basically instantiating chat and then sending me a message. And I'm going to be getting that live over here. I'm going to change that to dashboard. And that's, you see, that just triggered basically a whole nother set of downloads. So if you guys want to do that, I'm going to go back to this. There's some instructions there. And if you guys want to play along, that's cool. If not, I'll continue on to more FAQ or Q&A or questions and answers.
What is the password for Wi-Fi?
Oh, yeah. So I'll put it on the, I don't know if I can. I'll just write it here. There you go. We'll do a little reactive coding.
Excellent title for a slide, too.
What's that?
Excellent title for a slide, too.
So the wireless is BN or something. Sorry. There. Where's your laptop, dude? Oh, yours, yeah. I can let you use mine if you want. No, okay. All right. I did the app is you can just basically run it as a local file. You don't have to deploy it anywhere. Index.html. Huh?
First person get a message up there wins a book.
Holy smokes. You can just download the zip, explode it, load up index.html, follow the breadcrumb trail. Very much the same as we did with the demo app here. Ember, huh? That was you that sent the Ember message? Oh, you're mean. So yeah, I'll say a couple of things about Ember, I guess. I'm not that familiar with the technology itself, but one of the things that I know Ember has problems with is that it has a lot of very particular conventions, and they exist in a kind of like a global object, which kind of goes against what modules are, right? So when your application is expecting things to be in a global module, you can do that, but the problem becomes then that some things have to be loaded in a particular order, because when you load a route, it has to find other stuff that is in the app.js or whatever you call that, your module. They have to be loaded in a specific order. And when I was trying to do it, and I'm like, okay, it seems like I'm just adding more burden here to the application than problems I'm solving. So I figured that it was more problematic to do it than to not do it. Oh, who is this little creeper? Uh-huh. All right, book. Was that you, John, that wrote it, or okay? Where's Brian? We need a book. I don't know. I can't tell. They didn't.
There's a wiki there.
Do you guys put in an email address in the message? Reveal yourself.
Just use Chrome.
What's that? Yeah, you can do that. Yeah, that's kind of cheating. But,
I'm pretty much a cheater.
come on, guys. There you go. Nice. Nice. You get a second book, huh? Somebody has a question? Oh yeah, what's up?
So if we are using a require, actually I have two questions. Simple one first.
Good.
The way it loads the files, does it create a script tag on the done dynamically, or
Yeah, it creates a script tag. If you try to use that approach, it's actually pretty interesting because script tags, you don't know when they're loaded. You kind of know at the end, but then Require.js goes through some kind of like timestamping thing to figure out if it's been loading, and if it's been loaded, if that's the script tag that belongs to a specific module that was required. So it does some crazy black magic. I don't even touch it, but it does it via script tags.
So that's the simple question. The other question is, if you have a project with require, and you are using only define, so with the dependencies, you are not using any require. I assume when it loads, when the whole thing loads, you are loading all your JS files,
Right.
So there's nothing on later on. So you just
You're done. Yeah. For you to be able to dynamically interact with it, you have to basically do a require at a later point.
yes.
Yeah.
So this is just effectively on the memory of the browser, similar to, say, concatenating all your JS files in the right order.
Yeah. Yeah. I mean.
There's Jay right there on the bottom.
Oh, nice. Yeah. That goes back to how you architect your application. I mean, if you want to load everything up front, you load it up front. If you don't, then
But this is effectively the same thing.
it's not effectively the same thing.
At runtime.
Well, there is one key difference, right? When you're loading things at runtime and you don't have them minified, you're going back to the server to get that stuff every time. When you load them up minified, all of the resolution happens internally. So Require.js will figure out if that module has already been loaded. So when it actually executes that script that comes back, the execution path will basically say, okay, define this module, and it registers that as a resolution already. And the way the minification works is that there's a concept of creating a module that has an ID. You can actually you can go out and create a module, and you can give it its name, the name that you actually want to do, that you want to give it. You can call it module Miguel, regardless of the file that it exists in. And then when you require Miguel, Require.js is going to know what that module means. So that's something that RJS does behind the scenes. It actually goes through every one of the modules that you're basically minifying, and it will put a name in it. So what that will do for you is that the minification process then is going to have these modules registering themselves with a name at runtime, actually at download time. So you download the whole thing, all these modules are downloaded, they get executed at that point, and they actually get registered internally. So when you make a require for something, the stuff is already registered, you don't have to go out in the network. The reason Require.js goes out to the network is because you're requiring something that doesn't exist in their cache system, in the registry. But once it exists in the registry, it's never going to go back out. So if you are very aggressive and you load all the stuff up at front from a minification process, then you're not going to make any other network calls. And that's, the minification process handles CSS and HTML and stuff. So when you minify, wow. I know this guy. Cool. Very cool. We're waiting for it. I'm waiting for it. I'm going to flip this table and kill somebody. Hey! That's cheating. That's so easy. You got to do something a little... No, I'm kidding. No, this is good. Don't be evil. It's going to continue popping every second, so thank you, dude. Thanks, dude. Thanks, new guy. I mean, it's in the server, so every time I'm polling against my server, so Mr. Smarty Pants over there just. Oh my God, that is funny. All right, I'm gonna have to kill alerts because this is crazy. Yeah, well, damn it. So, we'll see if I can figure this one out. It's dick. All right. Oh man, didn't bust the cache. So you see, this is a problem with busting cache, right? I made a change in my app. And it didn't register because the versions are the same. I would have to make a change in the version for this to register, or just clear the cache in my browser. But if I had made a change in the files, in some file, and I changed the version, that's automatically going to tell the browser just download everything that you need to download. What's up now? Don't do anything with the document body because I don't want to start chasing things down. Cool. What's going on? Somebody's probably trying to do something real evil with me. Yeah, I don't know what that even means. Yeah, as long as it's crashing jQuery, I'm all set. All right, cool. Well done, guys. This is great.
And it's over.
Are we done? All right. So, future of Require.JS is going down the drain. Sorry, guys. Require.JS is going to be killed whenever IE10 dies, which is going to be probably in the next 20 years. I mean, you see how long it took to kill IE7. So you guys have a lot of room for using Require.JS, but the future is looking very bright. Love the stuff that the ECMA folks are doing with imports and stuff. It's looking really good. If you haven't had a chance to check it out, CES, Harmony, they're the ones that are driving a lot of this. And there's a lot of stuff going on with implementation. There's the concept of transpilers. I didn't know what that meant. I had to translate it to Spanish to be able to know what that was. So what the transpiler does is that it goes through your ECMA 6 compliant code and converts it to ECMA 5 old school stuff. And it makes it work really nice. RJS. Guys, I will show you that configuration just so that you don't ask that question again. RJS is so big, it's a talk on its own. I could talk about this for longer than I can talk about Require.js. It handles things that are for libraries. I use it a lot because I create quite a few little libraries that I use for my projects. And I build a lot of inner dependencies because I like to create my libraries that are based on little modules. And the way I concatenate them is that they are then created as a standalone little library. And that is entirely very different than creating an RJS config for an actual application. So, and the configuration for RJS are just way too many. And it's very specific to the app that you're using. Somebody asked about how do you basically do multiple pages that share a same module. I can talk about it. I can tell you how to do it. The problem with it is that it just takes a lot of time to explain all of those edge cases. So that's why I just didn't want to spend too much time on it. CommonJS folks, Kevin influenced a lot of this. Amazing stuff. He basically came up with something back in, I don't know, dog years. Web is in dog years. So when we say 4 years, that's like dog is about to die. So 5 years ago, or 6, I don't know exactly, there were a lot of people trying to do modules and stuff and coming up with their own little system. And this Kevin guy and a few other folks started up a mailing list and started up the whole CommonJS thing. I think it was called server.js at some point, and it was renamed later to CommonJS. It's just a flavor of a script loader. It's different than Require.js because we have different requirements on the browser. Some people would say that it's more important on the server. I say it's more important on the client because that's where I work. So it's just differences in opinion on which one is right, which one is wrong. Browserify. It's a tool that basically allows you to take a lot of the Node plugins, Node packages from the NPM ecosystem or whatever, and then you can package them up and you can then consume them in the client. So that's actually a very cool tool. It's coming up and it's already out, but it's actually picking up a lot of steam, or it's picked up a lot of steam, and a lot of people are preferring that system because one of the problems with Require.js is that it's very, very verbose in larger applications. It's very ceremonial, as some people call it. I don't think that as much because you can put an array of an array of little strings that tells you which files you're requiring, or you break them up into separate require statements. Both ways you have to write what things you need. So I don't know which one is better in particular. But Browserify allows you to basically load up this CommonJS compliant things from Node. It loads them up in the browser. Amber, sorry, no Amber for me. It'd be cool though. I'll be very happy to work on a little sample app with you if you want. It's pretty cool. Those are the things that people kind of asked about. Anybody has any comments on this? Open mic. Free bird.
That's good.
Light reading. Light reading is pretty intense, but this is actually pretty important. And you know, if you're not familiar with that concept, it's a very, very important concept in just a module system. And JavaScript module pattern in depth, it's actually very good too. I'll be posting this thing up so you don't have to type them down real quick. If you want them right now, just send me an email and I'll respond right now and I'll attach this thing. So that's it, guys. Thank you so much. It's been great.